Yeah, welcome to the new session of your engineering mathematics. So in this session, I will go with the concept called as probability and statistics. Probability and statistics. Yeah. So in this probability and statistics, so it is also the branch of mathematics. Generally, we'll go with the different analysis here. So actually probability means what? Simply you can call it as the chances, occurrences. And similarly statistics means it's a part of your what you can take a simple example. Statistics means what ma? If you take an example of your college only, so they are maintaining your data, statistics data. So in which semester you are having the different marks and percentage, what is the percentages, what is the aggregate. So like that they will maintain you the different types of the statistics based upon their criteria. Am I right or not? So that comes under the part of your statistics. So when come to the part of your probability, so I will tell you an examples. So we often speak the sentences like suppose if I take an example, we can speak the sentences like possibly he will come today. If I take an example, possibly he will come today. And the other sentence we will call it as it is impossible that he will come today. So likewise these are the different sentences. See, just taken an example for understanding this purpose. Okay, possibly he will come today, and the other sentence is what? It is impossible that he will come today. Am I right or not? So such type of the numerical study of these certainty and uncertainty. So there will be certainty and uncertainties are there. Am I right or not? So in these certainty as well as your uncertainties, so here the subject matters the part of your what ma? The probability. Clear with my point? So here in order to discuss the part of your certainty as well as your uncertainty, here, see if you observe the sentences here, so there will be certainty and uncertainty will be there. Am I right or not? These in order to deal this certainty as well as your uncertainties, so here certainty as well as your uncertainties, so usually we will call it as the uncertainty ma. Am I right or not? Probability means the uncertainty only, right? So to deal these, you people require what? In order to deal these things, it matters a lot of the part of your what? The probability concept. Am I right or not? So usually the probability means we will go with what ma? And uncertainty we used to call it as. Am I right or not? Yes, uncertainty. And very peculiar example. So suppose if I take one more example so that you people will have an idea. Suppose if I take an example, it's a best example. Let me take for understanding purpose. I'm just taking here, right? So can you take the example of this one? Yeah, this is very peculiar example ma. With the same thing, if I take yeah, can you tell me what is the difference between these two examples? Yes, obviously people will have a laugh. Am I right or not? Sir, if dog bites a man, it is a common procedure. Am I right or not? So it will happen. So if it happens like that, they'll suggest you something that and all. So you have to take the injections. That like that, they will tell you it as. Accordingly, you will follow it as. But this situation, if this situation is happened, if the second situation, if I take it as a first one, this if I take it as a second one, right? First situation is common, but second situation is what? It's what? It's a complication. Suppose if this event, suppose if I'm taking these two things, if I take it as the events now, if I take these two things as an events, so what usually you will take it as? If it happens like this, am I right or not? So suppose it happened in a remote place, in a small remote place. If it happens, am I right or not? This occurrence of this event, it happened in a small remote place within a fraction of seconds. If man bites a dog, that situation happened in a small remote place. So obviously that will what? The day will be overall all the news channels like TV9, 10, ZX, like that, different news channels, they'll scroll this news only. Am I right or not? So that means that the occurrence of this event, see, first one will be what ma, the probability of occurrence of this event is what, probability is what ma, more. Then what is the information? See, if it happens like that, then they will call you it as what, yeah, it is common thing only, then they will go with as. So probability of occurrence of this event is what, more, but information is less. But here the situation, what is the situation? Probability of occurrence of this event is what ma, less. Am I right or not? And information is what, information within a fraction of seconds, all over the world it will scrolls down. So this is how, in order to deal these things, we will go with respect to what ma, the concept of your probability. Getting what I'm saying here? So this will help say a lot of things. So I think you understood, I hope you understood these things properly. Am I right or not? So probability means it is an uncertainty ma. So in order to deal these things, we will go with the concept of your probability and statistics. Clear with my point? Yeah, again, you people will have a doubt that, sir, in this probability, what are the topics you are going to cover here? Am I right or not? Yeah, so we will see some of the basic probabilities ma. So like, to understand the concept of your probability, first you have to understand the things with respect to your permutations and combinations. So based upon these permutations and combinations only, the probability will come. Am I right or not? So if you are be perfect with the concept of your permutations and combinations, then it will be easy to understand the concept of your probabilities. Okay, clear? So that is the part of your what, the probability and statistics part. Then after that, slowly we will introduce. If I see the basic probabilities, I will go with respect to of what, like addition theorem. What is addition theorem? What is the multiplication theorem? Right? Then different types of probabilities like conditional probability, right? So like Bayes theorem, then you people will have different criteria. Then how I have to distribute the data? So that is a probability distribution function, density functions. Am I right or not? So whether it is continuous distribution or discrete distribution, all those things comes under the part of your probability and statistics. So finally, some types of distributions like binomial distribution, Poisson distribution, as well as your what ma, the Gaussian distribution, which is also called as the normal distribution. That we will see in the part of this probability concept. Then we will go with respect to your statistics part. So in the statistics part, we will see the data, how we are going to arrange the different types of your data. So what do you mean by the open data? What do you mean by the closed data? Right? So how we are arranging the data? So what is a mean of the data? What is a median of the data? Right? So what is the mode of that particular data? So how I can able to arrange? So these are all we'll see in the part of your statistics part. So this is the ideology which you have to cover the part of your probability and statistics. Clear? So that is the part of your probability and statistics. Yeah, so in that, first let me take the different ideologies ma. First I will concentrate the basic concepts. First I will go with respect to the basic concepts and formulas in the part of the permutations and combinations. I'll just go through it, the basic concepts of your basic concepts as well as the formulas in the part of your permutations and combinations. First let me take this. Okay, yeah, out of which, to understand this, first I have to give you the part of the fundamental rules or fundamental principles of the counting, which is called as the fundamental principles of counting. The fundamental principles of counting are simply you will call it as the rules of counting. Right? Yeah. To understand this, let me take a simple example. So that is, suppose if I have some dots on the board. Let me take these dots. So I'm just taking these criteria, simple things. Yeah, these are the dots. See, Here if I want to count these dots, see if I want to count these dots, so I cannot able to go for, so this is 1 2 3 4 5 6 7, not like that. So here we will go with what, mind, these smart technologies, you people have to go with what, in order to count these criteria, what you will do it as, what you will perform it as, yeah, how many number of rows are there. Here I have 3 number of rows are there, then how many number of columns are there, which is in the form of your matrix form. So 1 2 3 4 5 will be there, so which is this one. So usually we will go direct with respect to what, 3 into 5, which is nothing but what, 15, you will tell directly. 3 into 5, which is 15, you will tell directly. So that is how you will make your life as a simple, am I right or not? So no need to go for from 1 to 15, you know, you cannot able to count these things, am I right or not? So such that here you used here the concept of what, the conjunction of what, the conjunction of what, here this conjunction is nothing but what, the multiplication conjunction, am I right or not? So this is a rule for what, and conjunction, am I right or not? So such type of things you people have to keep in your mind. So there are 3 different types of rules are there, there are 3 different types of rules will be there. Those are all nothing but what, one is rule of R, and the other one is what, rule of and, rule of and. The next one will be the factorial, that is a factorial of factorial, so which used to call it as n, that is n factorial, that will be what, that will see it as. So usually this rule for R means what, suppose if I take m things and n objects, m and n if I take it as, so you will have it as what, rule for R means what, usually you will do it as what, m plus n. Similarly this used to call it as what, rule for and means what, m into n used to call it as. So simply this rule for R, this rule for R we will call it as what, the addition, that is addition. Based upon that, people will have a addition theorem, and rule for and you will have it as what, the multiplication, am I right or not? So these are the 2 different rules which you will perform in the part of your what, the concepts of your what, the permutations as well as your combinations. Then you people will have a doubt where I have to use my R conjunction and where I have to use my and conjunction, am I right or not? So let me give you an example so that you people will have an idea, right? So take one example based upon this. Take an example, so that you people will have an idea, right? So let me take an example. See, you are listening the online classes, so you got bored, so you need to refresh it as. So you need to refresh. So after finishing of your class, the first thing will be in your hand. In your hand, you people are having what, you can able to see, or you can able to watch 3 movies. After the 3 movies, you people will have a 2 plays, whatever the games you are having, that you can do it as, am I right or not? So here what I'm mentioning you here is, in the first case what I'm mentioning here is, after finishing of your online classes, so you have an free time. In that free time you can utilize either these 3 movies or what, this 2 plays. So that means here if you observe, here you are if you observe this 3 movies means what, I can take it as m1 m2 m3, 3 movies are there. Then plays 2 plays are there. Plays means what, play 1 and play 2 will be there, am I right or not? So here we are having 3 movies and 2 plays are there. So what I told you is this first case. In the first case what I'm mentioning you is, after finishing up your online classes, either 3 movies are there or 2 plays are there. So in such a case, which conjunction you people have to use it as? Which conjunction? Either of this means what, the conjunction R you people have to use it as. Either R means what? Either this means you have to use the conjunction called as what? The R conjunction. So which is nothing but what? 5. Am I right or not? The conjunction what you people use it as? R conjunction. So this is the first case of this one. The same thing if you have the another case, if I take it as, you have 3 movies and 2 plays, am I right or not? So this case, in this what you people have to do is, you have 3 plays and 2 movies and 2 plays are there. So you must have to take the things with respect to what, 3 movies along with 2 plays. So that is how you people have to manage this one. So how you will manage it, that again, how you people will do it as 3 movies as well as 2 plays. So that means that the meaning for that is what? The meaning for, yeah, In this you are having an option of that what ma. So 3 movies as well as 2 plus you people have to do it as. So now take an example that is. So I have in my hand 3 movies followed by what 2 plays. That means that after each and every movie you have to cover 2 plays, right or not? So that is a play 1, a play 2. Here also play 1 and play 2. Here also play 1 and play 2. Am I right or not? So earlier case is what ma? The first case is what actually? Either of that one. Either you can go with the movies or you can go with what? The plays. But the second case is what? So you have to take movies followed by what ma? Plays. So first movie if you are completing, you must have to take it as what? 2 plays. That is 1 and 2 plays. So hence you people will have what here. So likewise 3 movies followed by 2 plays means you will have it as what ma? Like 1 2 if I'm going. So finally I'll have it as what? If you count it as, you will have total what ma? 6 will be there. Am I correct or not? So here 3 plays will be there and 3 movies are there and 2 plays are there. So here the conjunction what you have to use it as? The conjunction I have to use it as what ma? What? The and conjunction I have to use it as. So by using that and conjunction I used to get it as what? The value as what ma? 6. So this is the most useful criteria. So maybe some of you got this point and someone they won't get it as. So for them again I will take one more example. Again I will take one more example. So let me take an example. See, I want to travel. I want to travel from place A to place B. I want to travel from place A to place B. Am I right or not? This is one example. So there is no direct path from A to B here. So the example is I want to travel from place A to place B. Am I right or not? So what I got is there is no direct path from A to B. So there will be another path called as C. So there will be another path called as C. Via C I have to travel from A to B. This is the criteria. Am I right or not? So here if you observe here again from A to C, from A to C I have many more routes. Am I right or not? I have many more routes. So like 1 2 3 routes are there. From A to C I have 3 routes are there. Then again from C to B, again C to B there are 2 routes are there. So which is 4 and 5. So now my aim is what? I need to travel from A to B. I need to travel from A to B. So there will be 2 options here if you observe properly. So that is nothing but what? 2 options, not 2 options. Why I have to follow it as? So that is first I need to travel from A to C. Then I have to go with respect to what ma? I have to go with respect to what? This is C to B. I have to travel it as. Then only the complete travel will be finished. Am I right or not? So if you observe here from A to C, what are the possible ways you are having here? From A to C I have 3 things and from C to B I have 2 things here ma. So now my aim is what? My aim is what? Either A to C or C to B, or compulsory A to C and C to B. Compulsory I need to travel. See, if I want to travel from A to B means these 2 things I have to finish it as. Then only the complete travel will be existing. Am I right or not? So here which conjunction I have to use it as? Properly which conjunction I have to use it as, whether it is or conjunction or and conjunction, or conjunction or unconjunction. So obviously here you people have to use it as what ma? And conjunction, which is nothing but what? So I have to travel first from A to C, then this one. So that means here if you observe here ma, if from A to C the first travel is not completed. After doing the first travel, then I have to go with what? 4th travel. So 1 with 4, next 1 with 5. Am I right or not? So similarly I have to travel. Suppose if I take a second example, from second means that is 2 to 4, next 2 to 5. Am I right or not? Then similarly 3 to 4 and 3 to 5. So likewise I have to travel that. So many things. How many things will be there here? The conjunction, which conjunction I have to use here? 3, that is unconjunction. 3 into 2, which is something but what ma? 6. So here the conclusion is what? To travel, in order to travel from A to B, I have total 6 possible cases are there. So 1 with 4, 1 with 5, 2 things. Then 2 with 4, 2 with 5. next 2 more, next 3 with 4, 3 with 5. So total 6 possible ways are there to travel from A to B via C. Am I right or not? So now the concept of your and I have to use this one. And to get more clarity, take one more example also. In order to get the same example, I will just extend more. The same example I will extend you here, nothing more than here. So here the same analysis. Here I want to travel from A to B only. Right. So here earlier case, only one thing I just consider it as. So via C I have to travel it as. So via C means there are possible cases. I told you earlier there are 3 different possible cases are there, A to C. So 1, 2 and 3. Similarly this C to B, I told you what ma? C to B, this C to B will be what? Yes, this is C to B, what I told. Yes, this is C to B is nothing but what? This is a 4 and this is a 5 I taken here. Am I right or not? Yeah. Here there is one more path. From A to B via D also will be there. So this is a one more path will be existing. So that is from A to D there will be some more paths you can take it as. So there will be some more paths means 5 it is completed here. So you can take this as a 6, 7, this as a 8 and this as a 9 you take it as. Right. Then similarly from D to B also you will have it as some different paths. Am I right or not? So let me take this one. So which is 10, 11 and 12 you take it as. So now here I have to do the travel, that is from A to B I need to do it as. So now if you observe, if I want to travel from A to B, now this is a different case compared to your earlier case. So I have 2 options here. So I can travel A to B with the different cases. Am I right or not? So there will be a 2 possible cases here. The 2 possible cases exist. Am I correct or not? If you check it properly, if I want to travel from A to B, there are 2 options. One, I will travel from A to C. Then C to B I can travel it as. This is the one option. Then the other option is what? I can travel from A to D. Similarly from D to B I will travel it as. Am I correct or not? Either of these options. So but earlier case is what? Compulsory things. Am I right or not? So let me try to get the point here where I have to use and where I have to use my R. Yeah, can you tell me what is how many number of possible ways from A to C, which is 3 and which is nothing but what 2 will be there. And from A to D you will have 4 and D to B which is nothing but what 3 will be there. Am I right or not? Yeah. Now can you tell me what is the possible ways from A to B via C? Here which conjunction I need to use it as? Which conjunction? Obviously I need to use the conjunction as what? And conjunction. This and conjunction I need to use it as. So I got it as what here? This is a 6. Similarly here also I need to use the conjunction as what? And conjunction I have to use it as. So by using this, which is nothing but what? 12. Am I right or not? Same as is of your earlier case. But see here, this is a different approach. This is what I done here. I want to travel from A to B via C. I have 6 possible ways. To travel from A to B via D, I have 12 possible ways. So now the total possible ways from A to B, how many total possible ways See, individually via C 6 possible ways, via D 12 possible ways. But suppose from A to B via C and via D if I want to travel, so which conjunction here I have to use it as? So I am having here plus conjunction, that is R conjunction. So total I have here what total 28, sorry, this is total 18 possible ways are there to travel. This is what to travel from A to B. There are 18 possible ways to travel A to B via C and D. Am I right or not? Only with respect to C 6 possible ways. Only with respect to D I have 12 possible ways. But via C and D now total in my hand total 18 possible ways are there. So this is the usage of what? The usage of your and conjunction as well as your what R conjunction. So I hope now you understood these situations. I hope you understood the way where I have to use my or conjunction, where I have to use my and conjunction. Am I right or not? So these are the rule for and, the rule for or. So based upon your rule for or, I use the addition theorem. Based upon your rule for or, I will go with respect to what ma? Sorry, and I will go with the multiplication. Rule for or means addition theorem. Rule for and means what? The multiplication theorem you used to take it as. So I hope you understood this situation. Am I right or not? Then the last one will be what ma? The factorial. Am I right or not? So that also you take it as ma. Factorial. Yeah, factorial. Am I right or not? So for this factorial, where n is what ma? N is a positive integer here. In this factorial, all of you know that properly. Factorial means n is a positive integer, where if I take n factorial value, here I can represent as what ma? N into n minus 1, n minus 2, and so on, 2 into 1, like that I can take it as. Am I right or not? So let me take an example. Let me take the factorial values. So if I take some 5 factorial, what is the value of your 5 factorial here? What's the value of your 5 factorial? N into n minus 1 into n minus 2. So like that, 5 into 5 minus 1, 4 into 5 minus 2, 3 into 2 into 1 you will have it as. So what is the value of this one? So if you multiply, you will get it as what? 120. Suppose if I take 3 factorial, 3 factorial if I take it as, you will have it as what? 3 into 2 into 1, which is nothing but what? 6 you can take it as. Am I correct or not? Yes or no? In this itself, you can go with some special case more. So this itself, if you observe some special case. So what is that special cases here? What is the special case? What is the value of your 0 factorial? Which is 1. The other one will be what ma? 1 factorial will be 1 only. So don't get confused. So these are the some of the examples with respect to your factorial. Getting what I'm saying here? Getting what I'm saying here all? Understanding now? So that is the part of your what ma? So which I can call it as a rule for or rule for and, as well as your the factorial. So these are the some of the fundamental principles of accounting or rules for counting part. Clear with my point? Clear with my point, all of you? Yeah. So this is about the thing with respect to rule for and, as well as your rule for or concepts. Okay. Yeah. Next, let me go with the concepts of your permutations as well as your combinations. Permutations and combinations. So let me take the thing with respect to the permutations and combinations. Yeah, can you tell me what is the thing with respect to your permutations and combinations, ma? With your knowledge, you know, maybe you people studied in your intermediate. Permutations means what? It's simply an arrangements. So permutations means what, ma? Simply it is nothing but what? Arrangements. Am I right or not? Permutations means simply arrangements, and combinations means it is nothing but what? The selections. Am I right or not? This is the part of your permutations as well as your combinations. So if I take the thing with respect to your permutations, so a permutation is, if I take the definitions here, ma, a permutation, you can take a permutation is an arrangement of all or a part of set of objects. A part of set of objects. This is the permutation. Similarly, a combination is a simply selection of all or part of a set of objects. Am I right or not? So that is the part here. What permutations means, it's a simple an arrangement. Combination means what, ma? Simply it is what? The selection. Am I right or not? So that is the reason why I represented this one. So here again, ma, so you have to go with respect to what? Permutation with repetition and without repetition. Am I right or not? Similarly, combination with repetition as well as your what, ma? Without repetition you people have to do it as. So let me take the thing with respect to your what the permutations with repetition as well as your without repetition. Am I right or not? So let me take first permutations without repetition. Permutations without repetition, first you will take it as, actually this is the part of your intermediate mark, but I'm just revising these things. So permutation without repetition. Permutation without repetition. So here you have to take it as the number of permutations of n different or distinct. You can take it as distinct means different only. Number of permutations of n different or distinct objects taking r at a time can be given as you know that, which is NPR. So n objects with respect to r taking, so that is NPR, which is nothing but what, n factorial divided by n minus r factorial. So this is the part of your permutations without repetition. So there is no repetition here. Getting what I'm saying here? Getting what I'm saying here? In order to understand this, you have to go with respect to what, the different examples. So if I take an example for understanding in order to understand the concept of here, so let me take an example. So let me take an example. So I need to arrange, I have 3 letters. So I need to arrange these 3 letters, right? I have 3 letters. Am I right or not? So I need to arrange these 3 letters. The first one is what I taken here, permutations. P means permutations, permutations without repetition. First one is what, permutations without repetitions. Yeah. So what is this one? Without repetition means what? You know that NPR, which is nothing but what, n factorial by n minus r factorial. Am I right or not? So here I have to go with respect to what, I have to go with respect to what? Yeah, give me the thing. Permutations, 3 letters with the 3 things. I have to take it as. From this analysis, how I have to do it as, which is nothing but what, 3p3, which is equivalent to what, 3 factorial divided by 3 minus 3 factorial. Am I right or not? So which is 3 factorial by 0 factorial. Again, you know that what, 3 factorial means what, 3 into 2 into 1, and 0 factorial will be what, 0 factorial will be what, 1. So hence total I have what, 6. So total I have what, 6 possible cases are there to arrange, to arrange these 3 letters without repetition. So that is nothing but what are those? I have 3 letters, which is A, B, C. Yeah, what are the possible cases I am having here? I will go with what, A, B, C. Next ACB with respect to this. Then similarly next one is what, BAC. Next BCA. The other last one will be what, CAB and CBA. So there are 6 possible ways to arrange these 3 letters without repetition. Am I right or not? So these are 3 letters with the 3 places. This is one of the example. Am I right or not? This is one example, 3 letters with the 3 spaces. Similarly, in this itself, we will take one more example. 3 letters with the 2 spaces, 3 letters with the 2 places. Am I right or not? See here, ABC with the 3 things. Let me take the other will be what, 3 letters with 2 places. Yeah, how we will do it as? But earlier case is nothing but what, earlier case n value will be 3 and r value is also what, 3. That I directly taken there. Now in this case the value of your n is what? N is 3, but r will be what, 2. Yeah, how we will do it as? What is your NPR? NPR is equal to what ma? Which is nothing but what? 3p2, which is equivalent to 3 factorial divided by 3 minus 2 factorial, which is nothing but what? 3 factorial by 1 factorial ma. Again, which is nothing but what? You will have 6 place. Again, 3 letters with the 2 places means you will have it as what? 6 possible cases. So what is that? You will go with what? A, B, C, which is nothing but what ma? A, B, 2 places. A, B, BA is one of the thing. Next BC, next CB. Next one will be what? CA as well as your AC. So these are the possible bases. Am I right or not? So this is how you people have to go with the part of your what ma? Permutations without repetitions. Clear now? Getting what I'm saying here all. I hope you understood this one. Permutations without repetition means these things ma. 3 letters with the 3 places I arranged first, and then 3 letters with 2 places I arranged here. Clear? Getting what I'm saying here? Got my point there? Understood? Understood or not? This is the part of the permutations without repetition. Next, suppose if I go with the permutations with repetition. Next, if I go with the concept of your permutation with repetition. So permutation with repetition, if I go it as, let me take that also. Permutations with repetition. So here I am allowing with repetition. Here I am allowing with repetition also. So the number of P, that is the number of permutations, you can tell it as the number of permutations of n distinct things taking R at a time when each thing may be repeated any number of times is given by or is given as what? N to the power of R. This is very, very important. Permutations with repetition means n power R. This you have to keep in your mind. N to the power of R. N power R. Permutations with repetition means n to the power of R. You people have to do it as. Getting what I'm saying here? Understood? This is R. Yeah, let me take an example for understanding this. Again, same example. Earlier what I taken, the same example I'm taking here. Yeah, permutations with repetition. So let me take an example so that you people will have an idea. Yeah, permutation with repetition means what ma? First one, A, B, C. Yeah, this is 3 letters with the 3 places. 3 letters with the 3 places. So how you will do it as? How you will do it as here? That is what? N to the power of R, which is what? 3 power 3. 3 power 3 you will have it as what? 27. So what are the possible bases like that? What are the possible bases? A, next A, B, next A, B, A, next A, B, B. Likewise total you will have it as what ma? 27 possible ways will be there. Like that you people will have what? Total 27 possible bases are there. So this is one thing. Am I right or not? Next the same. You will go with what ma? 3 letters with the 2 places. If I go it as A, B, C, that is 3 letters with 2 places. If I go it as in this case again, what you will have it as? In this case again, what you people will have it as here? 3 square, which is what? 9 places will be there. Can you tell me what is that 9 place? Earlier if I allow the repetition, If I allow the repetition, what you got it as here earlier will be AB, BA, then what BC, CB I written, then last one will be what ma CA and AC will be there. So then if I allow the repetition, what I will have here, if I allow the repetition, AA will be there, BB will be there and CC will be there. So total I got it as what? Total 9 things will be there. Am I right or not? So this is the permutation with repetition. So that is how you people have to follow the criteria with respect to these things. Understanding what I'm saying here? So this is the part of your permutation with repetition as well as your without repetition. So let me take some properties, that is with respect to your permutations. What are the different types of your properties you are having here? Yes, let me take some properties that you know that. Am I right or not? The properties we can mention you here. Properties of your what? The permutations. Yeah, properties of your permutations. You know, first one is what? What is the value of your NP n factorial? Sorry, NP n value will be what? Then NP1 will be what? Then a third one, NP0 will be what? Come on, tell me that. Yes, can you tell me this? Yeah, directly can substitute ma. What is your NPR actually? N factorial by n minus r factorial. Am I right or not? With the first example, here both are case what? N factorial. So hence if I substitute n factorial by n minus n factorial ma. Am I right or not? So which is nothing but what? N factorial by which is 0 factorial. So finally I'll get it as what? The answer is n factorial. Similarly this also n factorial divided by n minus 1 factorial you will have it as, then this n factorial I can represent it as n into n minus 1 factorial ma divided by n minus 1 factorial. Am I right or not? So in this n minus 1 factorial gets cancelled. You will have it as what? The value n. Similarly this also n factorial by n minus 0 factorial. So which is nothing but what? N factorial by what ma? N factorial by n factorial. So these two will get cancelled. Finally we will have answer as what? 1. So that is how you people will go with the different ideology. Am I right or not? Getting what I'm saying there? Right? Clear now? So these are all the some of the properties of what? The permutations. Similarly, can you go for the same analysis what I done for these permutations? You can go with respect to what? The combinations also. Am I right or not? So let me take the combinations without repetition. First one, combinations without repetition. So let me take that combinations without repetition. Yeah, let me take the another one. Combinations. First one will be without repetition. Yeah, combination without repetition. Take down number of combination of n distinct objects taking R at a time can be given as what? You know that combinations means NCR, which is equivalent to n factorial by n minus r factorial into r factorial. Am I right? Am I right or not? So this is this part. Am I correct or wrong? This is combinations without repetitions. Clear? Yeah, the same. Whatever the thing I had taken for what? The example. So you will have it as what? The same example. Here also I will consider it as combinations without repetition. So here I will arrange 3 letters. So let me take ABC only ma. Right. So I need to select these 3 things. So 3 letters three letters with the three spaces here, three letters with the three places. So how many ways I can able to select these things, where NCR is equivalent to what, ma, which is what, 3C 3, that is nothing but what, 3 factorial divided by 3 minus 3 factorial into 3 factorial, so which is nothing but what, if you do it as three things, so that is ABC. I can arrange it as what, only one way. I can select only one way, that is three places with three letters. That is one way I can arrange it as. Then similarly one more example, the same thing I can do it as same example ma. So ABC only, but here three letters with the two places, three letters with the two places. Yeah, how you will do it as NCR. So here N is 3 and R is 3, but here N is 3, R is 2. So give me that. 3C2 is equivalent to 3 factorial by 3 minus 2 factorial into 2 factorial, which gives you what, 3 factorial by 2 factorial. So you will have it as what, ma, 3 into 2 factorial divided by 2 factorial. So this 2 will get cancelled. You will have it as what, 3 different things. Am I right or not? So what are the possible bases here? You will have, what are those? AB, BC and CA. Am I correct or not? AB, BC and CA will be there. Clear? This is how I have to go with respect to what, ma, the combinations without repetitions. Combinations without repetitions. Am I clear? Yes or no? You got my point there or not? You got it now, yeah? Yeah, that is how I have to do it as. Next, similarly, combinations with repetition. So go with that combinations with repetitions, ma. Combinations with repetitions. Yeah, combination with repetition, if I go it, so what you will have there again, the number of combinations, of n distinct things taking R at a time, when each thing may be repeated any number of times, can be given as earlier it is for permutations with repetitions. I gone with respect to what, ma, n power r. Here you have to take it as what, n minus 1 plus r into cr, ma. N minus 1 plus r into cr. This you have to do it as n minus 1 plus r, n minus 1 plus r into c r. I have to do it as. Getting what I'm saying here? Clear na? That is how I have to do it as, right? So this is the combinations with repetition as well as your combinations without repetition. You can go with the examples, ma. You can go with the examples. Am I right or not? So try to do that. You can go that the things, ma. So combination same, ABC with 3 letters, ABC with 2 letters. So try to do that. Combinations with repetition. Yeah, take an examples for the combinations with repetition. So let me take an example, ma. So if I take the examples, that is 3 letters with 3 places. Yeah, so what you will get it as? Check it out. That is ABC the 3 things. So we'll have it as what? 3 minus 1 plus 3 C3. Am I right? Yeah. If you do it, which is nothing but what? 5C3. So which is 5C3 means what? 5 factorial by 5 minus 3 factorial into 3 factorial. If you solve it, you will have it as what ma? 10. Am I right or not? Yeah. So you will have a different possible ways. If you write it as so ABC, right? So ACB. Likewise, if you write and you have to apply the repetition also ma. So AAA, BBB and CCC. So total 10 things will be there. Am I right or not? So check it out. This is one of the things. Next, similarly, if I go with that second one, check it out. That also 3 letters with 2 places. 3 letters with 2 places. If I do it as, so what do people have again? What you will have it as? Must see, this is 3 things. Yeah. So here ABC, if I take it as, which is nothing but what? 2 things. So now if I want to calculate this one, yeah, n minus 1 plus r into cr. So 3 minus 1 plus 2 r, sorry, c 2 will be there. Am I correct? Yes or no? Yeah. What do we get as here? 3 plus 2, 5, 5 minus 1. So which is a 4c2 ma. So 4c2, if you calculate it as, you will have 6. Am I correct or not? So what are the possible cases again? AB, BC, CA. Then you have to apply what? AA, BB and CC. So these are the possible ways. So this is how you people have to go with the concepts of your what? The concepts of your what? The permutations as well as your combinations with repetition. So finally you will see the properties. Let me take the same as it is of your earlier properties only. Properties of your combinations. Then we will solve the problems based upon that. So let me take the properties here. What are the properties? Yes, yeah. What is your NCN factorial or NCN value? So take that. What is your NCN value, ma? And NC not and NC1. Give me the values for that. Can you give me the answers for that? Yeah. This thing directly they asked you. You know that NCR is nothing but what? N factorial by N minus R factorial into R factorial. So which gives you what? If I substitute N factorial divided by N minus N factorial into N factorial. So this is 0 factorial. This 2 will get cancelled. You will have it as what? NCN value will be what ma? 1. Then similarly, if you calculate this, your NC naught value will be 1 and NC1 value will be N. You will get it as. Check it out. Check it out ma. You will have an answer like that. Okay. So this is the part of your the permutations as well as your combinations ma. Right. So now let me take some problems, some examples. I will take an examples so that you can have an idea. Right. So let me take the thing, the problems. So actually this is not there in your GATE syllabus, but anyhow for understanding these concepts I'm just giving this ideology. That's all. Nothing more than that. Okay. So let me take the problems. You try to practice own also, not an issue. Yeah. 2 lottery tickets. Note on the question. 2 lottery tickets are drawn. 2 lottery tickets are drawn from 20 for first and second prizes. What is the permutation that? What is the permutation can be made? What is the permutation can be made? This is the question. Can you give me the solution for that? Yeah. What is the question? 2 lottery tickets they had taken from 20, right? For first and second prizes. For giving the first and second prizes. Am I right or not? So what is the permutation here? Which is nothing but what? You know that permutation NP R. Am I right or not? So which is nothing but what? The total n things will be what? 20 things. Out of which I had selected what? 2. Am I right or not? So I taken this one. So what is this? 20p2, which is nothing but what? 20 factorial divided by what? 20 minus 2 factorial, which is 20 factorial by 18 factorial. So this 20 factorial I can represent as a 20 into 19 into 18 factorial divided by 18 factorial. So the answer will be what? These two will be getting cancelled. So you will have it as what? Total 380 ways I can able to arrange those criteria. Clear na? That is how I have to do the things. Next problem. These are all the simple problems, nothing more than that. Yeah, for understanding the concept, I'm just giving here. Write down how many ways can a local chapter of the Indian Chemical Society schedule 3 speakers for 3 different meetings if they are all available on any of possible dates in a weekdays. This is the question. See, how many ways can a local chapter of the Indian Chemical Society can schedule 3 speakers for 3 different meetings if they are all available in the possible dates of what? The weekdays. So you know, for a week you will have what, total 7 days. Am I right or not? Week means what, 7 days, that you know that. Then in that weekdays means what? Monday to Friday will be the weekdays, that is 5 days are weekdays, weekends are 2 days. Am I right or not? So out of which, see, there are 3 different speakers with 3 different meetings if they are all available on the weekdays. Am I correct or not? So total 5 weekdays are there, out of which I have to select it as what? I have to arrange that as what, 3 things, so that I can make it as what, the total number of possible schedules. So based upon the arrangements, that is what, the total number of possible schedules are what? The total number of possible schedules are what, 5p3, which is equivalent to 5 factorial by directly I can represent as 2 factorial. So which is what, 5 into 4 into 3, that gives you what? Total 60 meetings I can able to arrange. Total 60 meetings I can able to arrange with respect to what, these 3 things. Clear with my point? Understood? Yeah, that is how I have to solve the things. Next, one more problem. Third one, the number of ways in which 3 cards can be chosen or selected from a total of 8 different cards. From a total of different 8 cards is. Yes, come on, tell me the answer for this. How I will do it as? Yes, yeah, there are directly they mentioned you here. The number of ways in which 3 cards are selected or chosen from a 8 different cards. So selection or chosen means what, the combinations you do it as. So that is 8c3 I can do it as, which is what, 8 factorial by 5 factorial, 8 minus 3, 5 factorial and 3 factorial. If you solve it, you will have it as what, 56. This is the thing. Am I right or not? Yes. Yeah, that is how you can able to solve the things. Next, can you try one more problem? The number of different arrangements or permutations are permutations consisting of three letters, each can be formed from the seven letters A, B, C, D, E, F, G, E's. This is the question. Yeah, out of total 7 letters, you need to arrange 3 letters. Direct statement. That is 7 P3, which is equivalent to what? 7 factorial by 7 minus 3, which is 4 factorial. So if you solve it, I think you will have it as what, ma? 210. This is the answer for that. Am I right or not? So try to check it out. You will get it as the answer like this. Okay. Yes. This is the part of that criteria. Okay. So likewise, you people have to solve the problems based upon what the permutations as well as your combinations. Can you try one more problem? I think it is a very peculiar and famous example in your intermediate, I think so. Right? Can you take that? Yeah, the number of different permutations of the 11 letter of the word Mississippi. MISSISSIPPI, Mississippi. Right, total 11 letters word it is Mississippi, which consists of 1M, 4 I's, 4 S and 2 P's is. This is the question. This is the question. Yes. Come on, tell me that. How I will get it as this. Come on, try to solve that. Yes. Yeah, how I can able to solve this one? The number of different permutations of 11 letter of the word Mississippi. So this is a total 11 letters word, ma. So which consisting of 1 M, 4 I's, 4 S and 2 P's. So that is, there is a repetition is there. So directly how many ways and how many permutations, which is a repetition. So directly you can do it as what? Total 11 letters are there. So which is 11 factorial divided by what, ma? 1 factorial, 4 factorial, 4 factorial into 2 factorial. So if you solve it, you will have it as what? 34,650. That you will have it as the answer for that. So try to check it out. So if you want the clarity of that, you can make a note, ma, actually, right? So there is a note point, one thing will be there. You can make a note point here. The thing is, maybe you studied in your intermediate. Maybe you studied this in that intermediate. Am I right or not? So number of permutations of n different things. Take the things with respect to this. Number of permutations of n different things. Things of which n1 are like n2 and n3 and so on, like that. This is given by n factorial divided by n1 factorial, n2 factorial and n3 factorial and so on. This is a note point. This is the note point what you have to keep in your mind. So based upon that note, you can solve these things. Okay. So it is the number of repetitions with respect to that criteria. Getting what I'm saying here? So these are the things which you have to keep in your mind to solve a problem, and some more problems you solve it Nama from your intermediate. So here there is no such type of things. Why I just given these criteria is this will be helps a lot to solve the problems based upon your the probability concept. Clear? Getting what I'm saying? So this is the thing it is required, that is what I can say, that the requirements for probability. So like permutations and combinations. So once we are be perfect with these permutations and combinations, that really helps a lot to understand the concept of your probability. So this is about this. So in the next session we'll go with the probability concept. Okay, so there the basic probabilities, and what are the terms you have to see it as, what are the different types of events, right? So and addition theorem, multiplication theorem, conditional probability, Bayes theorem, total probability, all those things we will see in the part of your the probability concept, right? Okay, yeah, fine, thank you.